You guys might be looking at that problem saying, well, wait a minute, that doesn't appear to be a problem that I'm ready to do, or that actually I've been ready to do for a long time. I know what 7 apples plus 8 apples are. That's 15 apples. What about instead of writing out the word apples every single time, I want to find out a shortcut. Maybe, how about the letter A? 7A plus 8A. That equals 15A. Remember, we used variables just to represent something that a lot of times we didn't want to write out over and over and over again. I don't want to write out apples over and over again, but writing A out, that was helpful. And so over time we just chose to use the letter X as a variable just to represent something else. Well, as we look at this idea of adding apples to more apples, the concept somewhat applies to square roots a little bit too. For example, say that I have 7 square roots of 2 plus 8 square roots of 2. And that's how I want you to say that. As you're doing your homework, I want you to say it that way. 7 square roots of 2 plus 8 square roots of 2. So how many square roots of 2 do I have? I have 15 square roots of 2. And that's going to give us a little bit of idea of how we add numbers that have radical expressions in them. Let me give you another one. The cube root of 5 minus 4 times x, cube roots of 5, plus 8 cube roots of 5. Well, how do we add those up? Well, the one other thing I want to distinguish here is that when you're adding up cube roots of 5, or adding up, you need to make sure that the index and what's inside the radical are the same. So everything here are cube roots of 5. So I have 1 cube root of 5, take away 4x, plus an 8. Well, this 4x is kind of messing me up a little bit because I can't really add a 4x and an 8 together. But I can add the 1 and the 8 to make a 9. This minus 4x is by itself. So there's all my outside stuff. I have 9 minus 4x, cube roots of 5. Feels like I want to tell you a little bit more on that problem, but I think to understand that a little bit deeper, it's going to require a little bit of practice for you for a little bit. One last problem I'm going to show you. I have 8 sixth roots of 5x. Take away 5 sixth roots of 5x plus 4 cube roots of 5x. Well, how am I going to add those guys together? Well, I notice right away that I have 2 different types of roots. I have a sixth root of 5x and a cube root of 5x. I can't add those two guys together. They're not the same animal. It's like an x and a y, or an apple and a banana. I can't mangle them up on this particular problem. So let's just count all my sixth roots of 5x's. I have 8, take away 5, so I have 3 sixth roots of 5x's plus 4 cube roots of 5x's. Now it doesn't matter that the 5x is the same. What does matter is that the index are different. And that's a key component to look out for. So I have 6 roots of 5x's, cube roots of 5x's. I can't add those guys together. So therefore, my final solution just appears to be that.